In this summary video, I'll be going over domain and range, its notation, and I'll also go over some examples. So to start off, domain, put simply, is just all the possible x values of a function or a relation, and then the range is all possible y values of a function or a relation. So, for example, if we have a graph of the function f of x is equal to x, right? So this would be the equation for a line. So this graph would look something like this. And as you can see from this graph, if you take any value on the x-axis, let's say we take a value of 1 from here, we can see that the value of 1 has a corresponding point on this line. And let's say we take the value of 4 here, and you can see that that also has a corresponding point on this line. So that's essentially what domain is, and it's basically all parts or all values from the x-axis that you can put onto this line and it would make sense. So the same thing is true for the range. So it's all possible y values that are part of this line. And you can take any value from this y-axis. Let's say we take a value of 3 from here. If you extend this horizontally, you'll see that there's a point here on the line that corresponds with 3. And you can even go into the negatives. So let's say you have -2 here. And you'll see that this point also has a corresponding point on this line. So all of these values are examples of the domain or the range. So these values of 1 and 4 correspond with the domain because they're on the x-axis, and these values -2 and 3 correspond with the range because they're on the y-axis. Now, not all x values or y values will fit into the domain or range of a graph. So we'll use this imaginary function as an example. So firstly, for this function, it starts from -infinity here. It goes all the way to -1, and then it'll start again at 1, and it'll keep going on to infinity. So these are the x values of this graph. And you'll see that these x values from 1 to infinity, all of them have a corresponding point on this graph. And similarly, for all the values below -1, these all have a point on this graph. However, some numbers like 0, so if you have a x of 0, this would not be anywhere on this line, so it's not part of the domain. So 0 is not part of the domain. And other numbers are similar too. For example, if you have a number 0.5 for x, you can't put that into the function because that's not part of this line right here. And the same thing is true for y values. So any y values above 1 have a corresponding point on this line, but any y values that are in sort of this range from any y values from the range 1 to -1 don't have a corresponding part on this line because this entire spot here is empty. Let's talk about how to describe domain and range using notation. So we know from previously that this graph goes from -infinity, it goes all the way up to -1, and then the x values stop before it continues on from 1, and it goes all the way to infinity again. So this is the domain of the graph. It goes from -infinity to -1, and then from 1 to infinity. Now to describe this in notation, there are two main ways. There's interval notation, and there's also inequality notation. So let's talk about the interval notation first. So what this is you're basically going to use parentheses, brackets, and then closing brackets and closing parentheses to describe the intervals where x exists on this function. So what the parentheses means is that the number is not included. And what the bracket means is that the number is included. And here's an example. So for this graph, we know that it goes from -infinity to -1. So let's write that out first. And since infinity isn't really a real number that exists, essentially, you have to use a parentheses since you can't include infinity in the domain. It's just any numbers up to infinity, right? So we'll use a parentheses. We'll go from -infinity. We're going to put a comma here. And then it goes from -infinity all the way to -1. And since -1 is included in this function here, we'll write -1 and we'll put a bracket signifying that this number is included in the domain. Now this function also has a gap here before it continues on at 1 again. And to show that, we'll put a union symbol, which is essentially a U, to show that we're connecting this half with the half that we're about to write right now. So we'll put, and since 1 is included in this domain, we'll use brackets. We'll write 1, and then put a comma, and then it goes all the way up to infinity. And since infinity isn't really a real number, and it's not inside the domain, we'll use a parentheses. Alright, let's use interval notation to describe the range of this function. So this is essentially going to be the same thing as the domain. We'll just be writing it for all the possible y values instead. So for this function, similarly to domain, it has a range from negative infinity. It goes all the way up to negative 1 here, right? And then it has a gap before it starts up at 1 again. And then it keeps going on to infinity. To describe the range, we'll have to say where the range starts. So it starts at negative infinity, and we'll use a parentheses, and then it's going to go all the way up to negative 1. And since negative 1 is included, we'll use a bracket, and then we'll use the union symbol to join the two sides before we start again from 1, and then it goes all the way up to infinity here. So we'll put infinity. So this would be how to describe the range of a function using interval notation. Alright, let's talk about inequality notation. And for this, I'll use a separate example. So let's say we have y equals 1 over x. And just looking at this equation, you can tell that you can't put 0 into this equation because if you put in the 0, what'll happen is you'll get the equation 1 divided by 0, and that is undefined. And so because of that, the x value of 0 is not part of this domain. And since 0 isn't a part of the domain, the only x values you can plug in are numbers that are not 0. And because of that, for the domain, you cannot have 0 as the x value, and for the range, you also cannot have 0. And let's draw out this graph. So the graph for 1 over x looks something like this. So you have the x and y axes, and then you'll have this part of the graph, and this part of the graph, and you're going to have asymptotes, which are lines that, imaginary lines essentially, that the graph will never touch, but it'll keep getting closer towards. So this imaginary line would be at the equation x equals 0, and this imaginary line here will be at the equation y equals 0. So the graph is never going to touch either y of 0 or x of 0. So this is what the graph looks like. And now let's describe this domain and range using inequality notation. So the way this works is that we're going to use the inequality signs to say what the x values can or cannot be. So for example, we'll be using the greater than sign, equal to, uh, less than, things like that, right? So let's start with the domain. So the domain, as we said, we can be all numbers except for 0. And to represent that, we'll write something like this. We'll say x, we'll use an E symbol that's kind of curvy, and then we'll use this R symbol. Now, what each part of this means is different. So for this E right here means is an element of, or is a part of the following set of numbers, and this R represents the set of all real numbers, right? So this statement is essentially saying the domain is that the x value is a part of the set of all real numbers. Now, this obviously isn't true because we have just said that here that the domain cannot have 0 in it. So to say that, we'll have to add a part to this statement. So we'll put a comma here, and then we're going to have to specify that x is not equal to 0. So what essentially this entire thing is saying is that x is a part of the set of all real numbers, but x cannot equal 0. Now, we can write it the exact same way for the range. If we were to describe the range, we'll say that the y values for this graph is a element of, or is a part of, the set of all real numbers. And we have to add to this that the y value cannot equal 0, as we have established up here. So that's how you would use inequality notation. All right, let's take a look at an example to put together everything we've learned so far. So Let's say we have the equation y equals the square root of x. Now, let's try and graph this first because that'll be easier to decide domain and range from. So we have a y-axis and we have an x-axis here. To graph this function, we'll just plug in values of x and then we'll find out what the y is. And first off, we know that you can't take a square root of a negative number. So first of all, we cannot plug anything that's negative into this equation. So therefore, we'll start off with 0. So y is equal to square root of 0, and then the square root of 0 is equal to 0. So we've plugged in 0 for x, and we've gotten the coordinate 0 back. So what this means is that 0, comma 0 is part of this function here. Now, let's plug in another number. Let's say for x, we plug in the number 1. So the square root of 1 is also 1. So this tells us that the point x of 1 with y of 1 is another point on this graph. So let's write that down here. So 1 comma 1 is part of this graph. And let's do one more just so we can confirm the shape of this graph. So we'll plug in y. Um, let's plug in x of 4. And the square root of 4 is equal to 2. So that tells us that the x value of 4 and the y value of 2 is on this graph. So let's go to 4, which is around here, and then 2. So this 4 comma 2 is part of this graph. So let's connect all the dots together, and then we end up with a graph that looks something like this. So it goes from 0 all the way to infinity for the domain, and the range also goes from 0 all the way to infinity, as you can see here. So now let's write that in the notation form. So I'll write one of these in inequality and then the other in interval notation. So let's start with the domain. So the domain goes from 0 here all the way up. So 0 all the way up to infinity, right? So we'll say the domain is 0, which is included in the domain. So we'll write 0 with the bracket, comma, infinity, and then we're going to close that off with the parentheses. And we're not going to use a union symbol here because there's no other part to add to this. We've already covered all of the domain with just this statement. Now, let's talk about the range. So we'll use inequality notation for this. So the range we know is that it goes from 0 to infinity, right? So it goes from 0 here all the way to infinity. But another way to say this is that the y values have to be greater than or equal to 0. And that covers all of the numbers along 0 to infinity. So to write that, we'll say that the y values have to be greater than or equal to 0. And this would be the range of this graph. All right, let's go over one last example, and this one's going to be a bit more complicated. So for the example, we're going to use square root 9 minus x squared. Now, the first thing to notice for this equation is that it has a square root in it. And we know that square roots can't have a negative under them. So we can't plug in any x value that would make what's on the inside negative. So first of all, I know what values I can plug in to make the inside 0, and those numbers are -3 and 3, right? Because if I plug in -3, we'll get the square root of 9 minus -3 squared, and -3 squared is just 9, so we'll get 9 minus 9, and we'll get the square root of 0. So the point, so write this over here, so the point, so x of -3 comma 0 is on this line, right? Or on this graph. And the same thing is true for 3. So you would do square root. And then if you plugged in a 3, you'll get 3 squared is 9. So this will turn into 9 minus 9. And this will also give you square root of 0. So another point that's on this is the point 3 comma 0. Now, if we were to make this number any lower, like if we were to plug in an x that's any lower than -3, here's what happens. So let's say we'll use -4. So let's say we plugged in -4 into the equation. So we'll end up with the square root of 9 minus -4 squared, and that'll give us 9 minus 16. And 9 minus 16 will result in a negative number, right? In this case, this will be a -7 down here. And it's the same thing is true the other way around. For example, if we were to plug in any number that's greater than 3 for the x value, like let's say we even do like 3.5, then we'll get the square root of 9 minus 3.5 squared. And although I don't know 3.5 squared off the top of my head, it's going to be larger than 9. And 9 subtracted by anything that is greater than 9 will result in a negative number, right? So from this, we know that the x value has to be between -3 and 3. Because if it's any lower, so if it's any lower than -3, it'll result in a negative number, like the example we have here. And if there's anything higher than this 3 as the x value, then will result in something like this. And both of these cases result in a negative under the square root, which we can't have. So now that we know this, we can start um, drawing the graph and then finding the domain. So let's plug in one last number so that we have enough points for a graph. And let's just plug in an easy number. We'll say that we'll plug in 0 for x. So we'll have y equal to square root of 9 minus 0 squared. And 9 minus 0 squared is just 9. So we'll have y equals square root of 9. And this will mean that y equals to 3. So that means that the point 0, comma 3 is also on this graph. So let's draw that out. So we have the y-axis, we have the x-axis. So the point -3, comma 0. And then we have the point 3, comma 0. And we also, parentheses, and we also have the point 0, comma 3. So we're going to connect this, and the graph will look something like this. It'll be like a semicircle. So this is the graph of this function. Now let's write the domain and the range since we have the graph now. And this is going to be a lot easier since we can look at this graph. So let's say we have the domain, and we can see from this graph that the possible x values from this function start from -3 and it goes all the way to 3. Right? And there's two ways of writing this. First of all, interval notation. So since it includes -3, we'll use a bracket. We'll write -3, and it goes all the way to 3, and it also includes that. So we'll close off the bracket. So that's one way of writing this. Or another way of writing this would be the inequality notation. So we know that for this domain, x has to be a value that's in between -3 and 3. So we can write it this way. We can say that -3 is less than or equal to x, which is less than or equal to 3. So this would cover all the values between -3 and 3, because we're saying that x has to be greater than or equal to -3, and we're also saying that x has to be less than or equal to 3, and that fits for the domain values of this graph. Let's talk about the range for this graph. So from this graph, we can see that the range values start from 0 here, so a y value of 0, and it goes all the way up to 3 and then stops. So let's write this down. So we have the range, and it goes from 0 to 3. So in interval notation, since it includes the 0, we'll put a bracket, write 0, comma, and then it goes all the way to 3, and it includes 3, so we'll put 3 and then another bracket. Now we can also write this in inequality notation, much like how we have done for the domain. So the or the y value in this case has to be between 0 and 3. So to write that, we can say that 0 has to be less than or equal to y, which is less than or equal to 3. So essentially what we're saying here is that so we're saying that the y value here has to be greater than or equal to 0, which is present here, right? The y-axis is the y values are either greater than or equal to 0 here. And we're also saying that the y values are less than or equal to 3, which is also present here because it's either 3 or it's something less than 3. So that's how you would find the domain and range for different graphs and equations.